morning everyone. I welcome you all my presentation. The topic of our presentation is on effect of substrate surface roughness on adhesion of titanium nitride coatings deposited by physical vapor deposition technique. I am Chandrashekhar A and my co-authors Dr. T.V.S.M.R. Bhushan sir and Dr. S. Venkat Prasat sir. This is the outline that I will be going through as the presentation progresses. Will encounter of the topics. Going to the slide, let us start with introduction. High durability and strengths are required for tools, engine parts and other parts used over long period of time. Coating technologies to enhance strength and durability include plating processes and various other techniques. Among these, physical vapor deposition or PVD surface treatment technology can be used to achieve high adhesion and hardness. In recent years, this technology has been increasingly used for various applications. The secret is the ability to form a film at the atomic and molecular level. Physical vapor deposition techniques have been utilized in automotive industries to reduce the coefficient of friction in sliding interfaces. Improvement of mechanical and tribological properties such as hardness, failure mechanism, wear resistance and corrosion resistance of tools, drilling, etc. is achieved by coating them with titanium nitride, chromium nitride, titanium aluminum nitride, aluminum titanium nitride, titanium carbide nitride, tungsten carbide, etc. Then, Thotic reported that excellent tribological properties of steels are achieved by the deposition of physical vapor deposition coatings. Titanium nitride coatings have made an industrially popular coatings such as low coefficient of friction, high hardness and wear resistance characteristics. Moving to the next slide, scratch tests are widely used to investigate the coating adhesion strength. In this research work, a systematic study was conducted on titanium nitride coatings on EN8 material. The effect of substrate surface roughness and thickness of the coatings on deposition of titanium nitride with EN8 substrate has been investigated through experiments with the help of scratch tester. Investigations were carried out using titanium nitride coatings of 1.5, 3 and 5 micron meter thickness and the three different surface roughness values of 0.02, 0.15 and 0.35 micron meter. Moving to the next slide is materials and methods. The actual chemical composition of steel substrate, that is EN8, has been analyzed with the help of optical emission spectrometer of thermoelectron equipment. The chemical composition of the substrate is reported in the table. Here are the results. Then, moving to the next slide, for the deposition of coating, the composition of targets used coating thickness and the summary of the process parameters are represented in Table 2. Here are the details of the deposition of titanium coatings on EN8 substrate materials. In the next slide, a GS Exuvert 200 MAT optical microscope was used to identify the microstructure of the substrate and coated material. And this figure, the Decomo scratch tester TR101 equipment showed in figure was used to scratch on the coated part. The stylus has 0.2 mm tip radius, Rockwell C spherical diamond indenter. The stylus was drawn across the coatings with a loading rate of 10 Newton per millimeter and sliding velocity or sliding speed of 1 millimeter per second. Moving to the next slide. In this figure, the optical micrograph of the substrate and titanium nitride coatings are depicted in figure 2. 2A shows the microstructure of EN8 steel. The lighter portion is perlite structure and the darker portion shows the ferrite structure. Whereas in the case of titanium nitride coating is gold yellow in color. That is 2B figure. In the next slide, figure 3A and figure 3B shows the value of normal load increasing along the stroke length. The normal load diagram indicates that there was a decrease in normal load at the end of the stroke length, and this may be due to the adhesive mechanism, which means complete detachment of the coatings from the substrate material. Next slide. The scratch test results indicating the values of traction force at various stroke length are illustrated in figure 4. For the EN8 substrate, the traction force increased linearly with an increase in the stroke length. The step-like behavior of the load variation and scratch track obtained on coating of the waviness in the shape of the curves decreased with what? Increase in the indenter normal loads. The greater slope of the traction force curve indicates that the share of elastic deformation increases the increase in stylus depth. Though the present investigation shows that the bonding strength of the coating increases with the decrease in the substrate surface roughness. The coating adhesion obtained on lower surface roughness, that is 0.4 micron meter, was superior to coating adhesion obtained on higher surface roughness substrate, that is 1.2 micron meter. In the conclusion part, materials with titanium nitride coating and different surface roughness have been systematically examined. The present investigation demonstrates that the thin film coating's bonding strength increases with a decrease in the surface roughness of materials. It was found out that titanium nitride coating with the substrate roughness of 0.4 micron meter exhibited a lower coefficient of friction and its wear. and here are the some of the reference. Thank you so much.